Hey everybody, my name is Calvin and welcome back to episode 9 of my Learn Python series. Today, we'll be covering part 2 of functions. The last functions video covered the basics of functions, that being defining and calling them, parameters, return values, defaults, keyword arguments, and using helper functions. In this video, I want to cover the extra function features that you'll use once your scripts get a little bigger, such as early returns, returning multiple values, flexible arguments, nested functions, mutability, docstrings, and importing helpers. This is a continuation of part 1. Be sure to check it out before you check out this video. The link is in the top right corner, and as always, the course repository will be linked in the description, and I always recommend watching the earlier episodes before this for the best learning experience. Before we jump into the lesson for today, I have an announcement I'd love to make. Have you ever wondered how the biggest companies in the world organize, sort, and analyze their data? It's from the work of data engineers. Data engineering is the backbone of modern analytics, business intelligence, and machine learning. Data engineers in the US earn around an average of $130,000 per year, with some even making over $200,000 annually. Hi, my name is Calvin Lin, and I wrote this book because this is something that I wish I had when I first started out. From databases, data warehouses, and real-time data streams, this book will give you a great foundation to launchpad your data engineering career. This is Modern Data, from Ingestion to Production. Available on Amazon, Apple Books, and Barnes & Nobles, so get your copy today. Hey, welcome back. I wrote a book called Modern Data, and I'd love for you guys to check it out. The links are in the description. Let's jump into the lesson for today. Let's create a folder called Lesson 9, like we usually do. And we'll create our first exercise, 9-1.py. In this exercise, I want to cover early returns and guard clauses. The section here is about writing functions that are easy to read. A common beginner problem that a lot of people run into is nesting way too much. You end up with if statements within if statements within if statements, and it becomes harder to follow what the function is supposed to do. Creating early returns fix that. We can check the invalid cases first, and then return immediately, and then the remaining code can really just focus on the normal case. This makes the function shorter and reduces indentation, which reduces confusion. We'll write a function here that applies a discount. The function has two rules. Price cannot be negative, and the discount percent must be between 0 and 100. If any rule fails, we'll return a none value. If the inputs are valid, we can compute the final price. We'll call this discounted price, and it'll take in two parameters, price and discount percent. Our first clause is if price is less than 0, because you can't have a negative price, we'll return none. And our second case here, if discount percent is less than 0, or discount percent is greater than 100, we'll also return none. In this case, neither of these clauses would make sense within the context of a function. So the best thing we can do here is return none. Really, you can return whatever you want, but in this case, none makes the most sense here. Then we'll have our actual logic. Discount amount is equal to the price times the discount percent divided by 100. And then we can return the price minus the discount amount. This clause right here is to make sure that since we'll be passing in an integer value for the discount percent and it's not going to be a percentage, if we put in 70 here, this will just equate to 70 over 100, or a 70% discount. And then we can see a couple of examples, such as 100 with a 20% discount. And here we'll expect 80, print discounted price, oops. Price 50, and with a 0% discount, that doesn't make sense. We'll do discounted price with a 50% price and a 0% discount. In this case, we'll just get 50 because there is no discount, and we can have a 0% discount price, and then we'll have a negative value for the initial price, which makes no sense, so this should return none. And have discounted price, 100, 200, which also makes no sense because you can't have a 200% discount. The highest value you can have is 100. We'll run this, and you can see that's what we get. Again, pay attention to the last two calls. We'll return none instead of just crashing. That makes the function safer to use. The caller can check for none and then decide what to do next. In this case, if we remove the guard clauses, we wouldn't crash, but we would get values that don't make sense within the context of the function. Let's move on to our next exercise. In this exercise, I want to cover returning multiple values. Sometimes, it makes sense that one function can naturally produce more than one result. In Python, you can return multiple values by separating them with commas. Python packages the return values together, and the caller can then unpack them into multiple variables. This is useful when the results are related and you don't really want to recompute anything. A common example is tax and total. Another can be min and max. And another example is a clean value plus a success flag. We'll compute tax and total in one function, then we'll pack the result into two variables. We'll call this function compute tax and total. It takes in a price variable and a tax rate that defaults to 0.0625. Again, remember here, if we don't pass in anything for the tax rate, it'll automatically default to 6.25%. But we can define this on our own. Tax is equal to the price times the tax rate. And the total is equal to price plus tax. And in this case, we want to know both tax and the total. So we can just do something as simple as return tax, comma, total. And what this will do is this function, compute tax and total, will give us both of these values in the return. And we can just extract them as variables like this. Tax, comma, total is equal to compute tax and total. Another thing to note is that these variables do not have to match what you're returning up here. So if anything, let's just do this. We'll have tx and tl, which stand for tax and total. I'll have $100. And in this case, we know that the total will be $106.25, and the tax is $6.25. So if we print the variable tx, we print the variable tl, we should get exactly that. And we see that's what we get. Again, we can do the same thing if we defined our own tax rate. So comma dot 1, say we had a 10% tax rate. Run this. $10 for tax and $110 total. The key detail here is the unpacking line. The tx and tl is equal to compute tax and total is the line that will assign the first return value to tax and the second return value to total. And the way you assign these are in the way that this returns. So I could do something like TL and TX here, and then the TL variable will hold the tax value, and TX will hold the total value, even though that doesn't make sense. You can see that these are flip-flopped right here. Let's move on to our next exercise, 9-3.py. The section here is about writing functions that can accept a variable number of inputs. You can see this in real code when you don't know how many values the caller will pass, or when you want to support optional configuration. There are two tools to help us do this. The first is star args, which collects extra positional arguments into a tuple-like group. You can loop through it like a list. And then we'll have keyword args, denoted like this. And what this will do is it collects extra keyword arguments into a dictionary. The keys are the parameter names, and the values are what the caller passed. First, we'll work on args with an add-all function. In this case, we'll accept any number of numbers and return the sum. We're using a loop, so you can see the logic instead of using Python's built-in sum operator. All right, we'll define a function called add-all, and what this will take in is star args. And we'll set total is equal to 0. And then for n, in the args that we passed in, well, total is equal to the total plus n, and then we'll return the total. Very simple function. And now we can pass in a variable number of inputs. So we can do something like print add all, and say we had 1, 2, 3, 4, 5, 6, 7, and we'll get whatever this adds up to, which is 28. Or we can just do print add all and do 100. And since 100 plus nothing equals itself, this should give us 100. Again, this will accept a variable number of inputs. And if we had add all with nothing, we'll expect to see a 0, which makes sense as well. See how there's a variable number of inputs? 0 here, 1 here, and 7 here. Next, let's touch on keyword args. We'll accept any number of named fields and then print them. The example here is useful because it shows you what keyword arguments look like and how you can loop through it. We'll define a function called print profile. And what this will take is star star kwrgs. And then we can loop through this in like so. For key in kwargs, we'll print key is equal to keyword args key. And what this will do is it'll index the kwargs dictionary. And then we'll run print profile. And then we'll have name is equal to Kelvin. We'll also pass in another variable called Boston. Oops. And we'll pass in a role variable as well. And we'll just set ourselves to student. And what this will do here is you'll see each key and its value printed. Key here is name, is Kelvin, city is Boston, and role is student. Keyword args is often used to accept optional settings like debug is equal to true, retries or is equal to 3, or timeout is equal to 10, and similar other configuration parameters in Python libraries. Let's move on to our next exercise, 9-4.py. And here I want to cover nested functions. What is a nested function? A nested function is a function that is defined within another function. It's useful when an inner function is only really meant to support one specific task. It helps keep our file cleaner because then we don't have to create extra global functions that we don't want others to call directly. Nested functions are also useful when the inner function needs access to a value from the outer function. That's how closures work. The inner function can, quote, remember values from the outer function call. We'll do a couple examples. One creates a customized checker function while the other keeps a helper function private within a larger function. Our first example is a minimum length checker. You call make min length checker 8, and it returns a function that checks whether a string has length at least 8. Let's write this function, def make min length checker, and we'll pass in a variable called min length. And then we'll have a nested function in here called check, which takes in text. See how this is indented within make min length checker? That is a nested function. And in this case, we'll return len text is greater than or equal to min length. And then simply here, we can just return check. And what this function will do is that the return function will check whether text is at least min length characters long. We can call it like this, is long enough. Call this our variable, and we'll have it be defined as make min length checker, pass in a value of 8. And the way we can use this is we can do something like print is long enough, and we can pass in whatever string. So say hello. This will get us false because hello with a character length of 6 is not longer than 8. But what if we did the same thing for something that was longer? And this is obviously greater than 8. I'll run this, we'll get false and then true. The thing to notice here is that check uses the min length, even though the min length is defined within the outer function. Min length is defined right here, and min length is used within the check nested function. Let's have a second example to hammer this home. Our second example, we want to normalize a list of names. We'll define a clean function within a normalize names function, because clean function is only needed within the context of the outer function. So we'll have this called normalize names, and we'll pass in a list of names. And then we'll write our function called clean name. And what this will do here is it'll return the name, stripped, and lowercased. And we'll have our clean names in an empty list right here. And then for n in the list of names, we'll append the cleaned result to the list. Then we'll return our cleaned list. So let's define an example right here. So we'll have a bunch of space here, and we'll have Calvin. We'll have Ava, all uppercase, and we'll have Noah with lowercase. Now we can pass this in. And we'll get our list of cleaned normalized names. Like so. The main idea here is pretty clear. We know that normalized names is the function that we want to expose, while clean is just a helper. We have no reason for a user to use the clean name in here. Really, we want to only expose the top level function right here. Let's move on to exercise 5. In exercise 5, I want to cover mutability when passing values into functions. The section here is about what changes when you pass a value into a function. Again, you need to know this because it affects bugs and surprises in real-life scripts. Remember, lists are mutable. That means a function can modify the list, and you'll see the change outside of the function. Integers and strings, on the other hand, are not mutable. You can create new ones, but you cannot change the existing value within place. This means if you want a new integer value, you have to return it and assign it. Let's check out list mutation first. We pass a list into a function, append to it, and then the caller will see an updated list. We'll have a function called add item, and it'll take in an items list right here, and whatever new item that you want to append. And we'll do simply items dot append and append the new item. We'll define a list of names is equal to Calvin and Ava, and we want to pass in a new name, Noah. And then we'll print our list of names. And what this will do is it'll append Noah to our list of names right here. Names here is the same exact object. Remember this. This is the same object here. All we're doing is we're going to be changing the list of names by appending to it. Because the list is mutable, we can do this. And we'll print this, and we can verify that our function works. Now, what if we had integers? We'll call add1. But unless we store the return value, the original variable stays the same. Let's define a function called add1. And I'll take in a variable x. And then x is equal to x plus 1. And then we'll return x. We'll set n is equal to 10. Add 1. And print n. We see that n cannot be changed here. We can call add1, but unless we store the return value, the original variable stays the same. So you might think that print n right here will give us 11, but that's not going to be the case. It'll just be 10, because integers are not mutable. So if we wanted to have 11 here, we'd have to do something like this. Set n is equal to add1, which takes in n from above. And now we have n redefined. Now, if we printed n, we'll get 11. The main point here is that with mutable objects like lists, the function can change the original object. With integers, on the other hand, you should expect to return a new value and then assign it. Let's move on to our next exercise. Here, I want to cover something that will be really important, and it's not really about coding. Here, we'll cover docstrings. Docstrings are about how you document the functions within Python. The docstring is a triple quoted string that's at the top of the function body. Tools can be used to display it, and it helps you later when you forget what your function does, because inevitably, you'll have a ton of functions. Say we wanted to write a clamp function and then include a docstring. We'll call help clamp so you can see the docstring show up. Let's write the function def clamp, takes in value, low and high, and what this will do here, this is how we define our docstring, triple quotes, and we'll document our function like so, keep value within some inclusive range. And have low and high. If value is below low, and then we return low. If value is above high, we'll return high. And otherwise, we'll return value. And then we'll write our logic. If value is less than low, we'll return low. If value is greater than high, we'll return high. And we'll resort to returning value at the end. Now, if we do this, clamp 5, 0, and 10, we'll expect our function here to return 5 because it'll clamp to 5. Print clamp, and say we had a -2, 0, and 10. We'll get 0 because our lower is 0. and we'll just have a normal example. So we'll have our high be 99 and 0, and then we'll just pass in 10. And here we'll just get 10. And then we'll also call a function called help. Let's see what this will do. We'll see that our function returns our expected values. But because we called this built-in Python help function, what this will do is it'll return us the docstring that we defined above. This is useful when we want to just reference what a function does. It doesn't make a lot of sense right now for us to call help within this small file, but what happens if you have a large code base and we're calling some random obscure function that's not really in here? What this will do is it'll automatically just give us information. So we don't have to go digging for it. You'll see this a lot. You'll see this a lot in real Python libraries. Let's move on to our next exercise, 9-py, and we'll also create a utils.py here. Here, I want to cover imports, specifically importing functions. The utils.py will hold our helper functions. We'll import them into a script file, and then we'll use them. This is normal Python project structure. Once you write multiple helper functions, we typically don't keep them all in the same file. We'll split helpers into a separate file and then import them. Let's write a function called def clean name, and I'll take in a name. And this is going to be the same logic from before, our nested function. But this is a helper function right here, and then we'll also have a compute total that we've also seen before. I'll pass in tax rate is equal to 0.0625. And we'll return price times the tax rate. We've defined these two functions within our utils.py. So let's save this. And then let's go to our script file, 9-7.py. We can simply import our helper functions from utils.py by doing from utils import clean name and compute total. And we'll know that we've successfully imported it if this turns green and these turn yellow. Might be different on your code editor, but this is how it shows up on mine. And we do from, the pattern is from utils, which is the name of your file, minus the .py, and then we can just directly import our function names. So what if we changed the function name down here to utility.py? We'll skip the changes there. But now we'll see that our import utils cannot be resolved because before we were importing from a utils file, but now it's no longer called utils. If we wanted clean name and compute total here, we'd have to also change this to utility. We'll see that the error correctly resolves. And now we can use this in here. So here we'll define a raw names is equal to Helen and John. And we'll also define a cleaned list that's just empty for right now. And then from here, we want to do for n in raw names, we'll append our clean name to the cleaned list up here. The cool thing here is that we're using clean name from utility.py. We don't have to redefine it in this file. Now, let's test this. Print cleaned, and we'll also do print compute total of 100. Remember, this will give us $106.25, and this will give us our clean names. Run this. That's exactly what we get. And that does it for the concepts I wanted to cover today. As usual, we'll do our git status, git add our lesson 9, git commit. We'll have lecture 9, which is functions part 2. We'll git push. And that does it for the exercises I wanted to cover for today. In this episode, we've covered function features that show up quickly once you stop writing tiny scripts. Again, early returns keep your logic readable. Returning multiple values let one function produce a complete result without any extra work. Args and keyword args let functions accept flexible input. Nested functions help you keep helpers local and build customized behavior, while mutability explains when a function can modify your data. We also want to know about docstrings, which are standard function documentation, and then imports are how you organize your helper functions across any files. In our next episode, I want to cover intro to object-oriented programming, things like classes and methods. Thank you guys for watching, and I'll see you guys in the next video.